So I've had people ask when I've tested videos off of old standard definition camcorders how I managed to get video that looked passable in HD, I guess. I mean, some people have said that it looks good. It doesn't look that good, but it's better than it could look. And so I'm not testing with the TRV-33 right now because that would require me to bust out the old HVX here and find my FireWire cable so that way I can do DV capture, because my computer with the FireWire port is out in the garage right now. But I am testing with a camcorder that uses the same kind of visual quality to it as the TRV-33, but it also has a slightly wider field of view. And this isn't even exclusive to the SR100 or the TRV-33 or whatever. This will work with just about anything that records 480i standard definition, like this Sony DCR SR85 camcorder. Realistically though, the methodology that I'm showing off could also be modified slightly to deinterlace 1080i video out of something like this XR500, or even the slightly newer XR550 here, which I really wanted one of these back in high school, but they were $1,500 when I was in high school. This one, I had to get a Sony microphone for this one because using the internal microphone, for some reason, this one gets radio interference from my Dexcom CGM that I have to wear because I'm type 1 diabetic now. Meanwhile, the XR500 does not get radio interference, even though it has exposed metal parts that I could come into contact with. I don't know what the deal is. But, you know, it's not exclusive to that. You could use that with just about any high-definition camcorder that you could get your hands on that shoots interlaced video, or even just about anything from the standard definition era, like these first-generation Sony DVD camcorders, which I've done a video on these before. They work surprisingly well as general-purpose DVD recorders. They just happen to take mini DVDs instead of full-size DVDs. It also works to get surprisingly usable footage out of these Panasonic cameras that use DVC Pro HD. For anybody that doesn't know, DVC Pro HD has limitations to it that make the HD footage that come out of it look not quite HD, and it's not even related to the format itself. I mean, it partially is, but it's mostly related to the fact that these kind of cameras have a 960 by 540 sensor array, and they, in unscientific terms, jiggle the sensor really, really quickly in order to capture more pixels than the sensor's actually capable of just as is. And even with cameras that are perfectly capable of high definition, like this one here, which is the same model that my college that I went to for broadcast ended up using when they upgraded to HD for the reporters to go out with. This one right here records perfectly respectable HD video, but it's interlaced. You can record progressive, but you're stuck with either 720p or 1080 at 30. With what I'm showing off here, you could actually get 1080p 60 out of this with the full color subsampling available. So you can do like cleaner green screens with this because it records 422 instead of 420. Not that it greatly matters at this point in time, because I've got a Canon XF605 which will record UHD at the same spec that the XF100 recorded HD, except this is 60 frames per second progressive. And this one I have to have a Zoom M3 recorder because its internal microphone is absolute garbage. Unlike the XF100, which has decent quality microphones, I don't know what the hell the deal with that is. I also got a Canon R5C here with the Tascam XLR adapter on it. This is an absolutely essential accessory if you want to record video with any kind of usable audio in camera. See, this Audio-Technica stereo microphone that I have on it is actually a really good microphone, but the camera's preamp is noisy and shitty. So you have to get this Tascam adapter if you want usable audio. That's a different video. Let's talk deinterlacing. Fucking hype influencer camera reviewer types being like, oh, this is an optional accessory that you can get. No, you need this if you want to get usable audio out of the video the camera records. Granted, cinematographers don't record audio in camera if they can avoid it, but this thing's cheap enough that YouTubers can get their hands on them. Deinterlacing, right. Alright, I'm not going to make any promises, but I'll make an attempt at being kind of concise about this. That means that there's some of this line noise that we're not going to get into too much detail over. If you have questions, just ask. So I've got this set up in a for loop. The reason it's notated weird is because I was using the simplified one and it wasn't working. I thought that I needed to change to something more specific. That didn't work, and then I found out that I had to escape out the parentheses in the Avisynth script that prints out to a file, because DOS for loops are fucking weird. I just never changed it back to the simpler statement. Either way, it works. The for loop basically runs for every mpeg file in a given folder. So all I have to do is get the mpeg files off of the SR100 here, dump them into the folder, and then put this batch file in the folder and run it. It finds all of the mpeg files, and then for every mpeg file, it will print an Avisynth script with inputs corresponding to the name of the original mpeg file, and then it will call up ffmpeg with some input things set to either a truncated or complete version of the mpeg file name, and it runs through that, and then it cleans up after itself and runs again until it runs out of mpeg files. The Avisynth script is where the magic on the visual side of things happens. So I've got the compatibility focused version of the LSmash source, because for some reason the regular one just doesn't work with the mpeg files off of the SR100. I don't know. That %% is the original mpeg file name, extension and all. Assume TFF. Standard definition DV and its derivatives are BFF. Everything else, mpeg files off of a DVD, mpeg files off of a hard drive or flash memory camera, AVC HD, DVC Pro HD, probably HD Cam, the files off of the XF100, which were retroactively renamed to XFAVC, even though it's actually MPEG-2, it's weird. Everything that is not standard definition DV or a standard definition DV derivative is going to be top field first. QTGMC. I've got it set using the placebo preset because it goes fine with the standard definition footage that I'm working with. And that only works because I have the prefetch set to 32. How I came to that, I've got 32 logical processors. Yeah. You will want to set that if you're doing QTGMC, because using all of the available threads that you have will give you a significant speed increase over just running QTGMC as normal. I think you can do something with like the set MT mode or something like that. I don't have the patience to deal with that because I've found that it's actually a pain in the ass to set. I just do prefetch because it seems to be an oversimplified way to do exactly the same thing. There's more to it than that, but this works, and if it ain't broke, you know. I wouldn't use placebo for high definition because even with 32 threads, it's still very slow, especially with this extra line noise that I have to repair the smeary picture that's inherent to the SR100. That would basically kill the performance for high definition, but for standard definition, it works fine. And yeah, line noise. Again, the picture off of the SR100 is kind of inherently smeary, so as good as QTGMC is, it kind of exacerbates that if you just run it with the preset, so yeah. If you really want to know what all of this crap does, you can read the wiki. So that's that. Then I've got the Spline 64 resize. That's the magic there that makes the high definition upscales that people were asking me about on older videos that I did in a similar fashion. So the way that this was oversimplified when it was explained to me years and years ago, Spline 16 is a softer upscale, Spline 36 is a pretty middle of the road upscale, and Spline 64 is a sharper upscale. It's way more nuanced than that, but that's the oversimplified version, and that's probably all that you really need to care about at this point in time because most of us are not video data scientists. 1920 by 1080 because bigger numbers go burr. Prefetch 32, I think we already went over that. And then truncated file name with the .avs extension. ffmpeg calls up the AVS script and the original MPEG file. Roll with me here. Codec AV1 NVENC, because I have a 40 series chip in this computer. Generous bitrate, intraframe, overkill audio codec, because it's better to have way too much than not quite enough. Line noise to mix down 5.1 to stereo without losing information from the LFE channel. Realistically, you would probably be fine using AC2. I'm just doing this because I don't want to lose the information out of the LFE channel. Autism reasons. Map 0V takes the input from that AVS input, pulls the video out of that, and spits it out to the video stream of the output file. Map 1A pulls the audio out of the MPEG file, runs it through that filter, and then spits it out to the audio stream in the output file. And then the output file is the truncated name of the MPEG, but with the MP4 extension. So that's what all of that does. I know that it's a lot of, information overload and stuff like that, but man, I tried to be concise, okay? I'm not very good at that. Now, how good could something like this possibly work? Judge for yourself, man. I'm literally using the SR100. I think we already established that at the very beginning of this video. All right. We're just gonna go ahead. So we've got our conversion file there. Mini USB. This is basically the same thing that you used to use with the PlayStation 3 controllers, for anybody that's wanting to get a generic replacement. Upside down for some reason. We're going to push HDD, set this to the side. MP root. We've got a whole bunch of MPEG files that we recorded. And we'll stick those right there. And this is going to take a second because it's running at a really slow USB 2 speed. Actually, this would be like high speed for USB 1 if I'm being completely honest, but I've tried a bunch of different cables and I can't get really any better speeds, so we're stuck with what we're stuck with. Alright. This thing away. Now, I'm going to add an extra step to the batch file so that way it just gets rid of the originals, but because I don't want those to go bye-bye, we're going to make copies and put them into there just in case this goes absolutely horrifyingly wrong. And then we're going to go into here. No, we don't want to add that into the loop. We want to add that right outside of the loop. And now we're going to run it. 130 frames a second on the placebo preset. I'll take it. There we go. And as far as these are concerned, we've got 18 items. Perfect. Now we can edit. The whole thing with these MPEG files too, DaVinci will not load them by default. You have to repackage them if you want to use them in their original form. However, you wouldn't want to because the deinterlacing in DaVinci Resolve is garbage. So if you got to repackage anyway, you may as well transcode to something that's going to be a little bit better. And if you're transcoding anyway, well, you may as well use a better deinterlacing filter.